Hello, we are team 6. Myself is Abhishek Sagar and the team members of my project is Chandrapal Singh and Lalit Kumar. So in this project we are aiming to establish the master-slave relationship between the two robots. The one robot is called the master robot and the other robot is called the slave robot. So what happens in this project that we are aiming to design a machine that will carry a luggage and will move after its owner. So our project basically consists of two parts, the obstacle avoidance part as well as the object following part. In the object following part, what happens that there is one robot called the master robot and it will move in some arbitrary manner in some direction. The slave robot is supposed to follow in the same direction as the master robot is going. In the obstacle avoidance part, what happens that the slave robot, while following the master robot, will also avoid the obstacles if it encounters any in its path. So some of the implementation details of the project will be discussed by my team member Lalit Kumar.
Hello, I will be talking about the object following part. So to follow the master bot, we have placed a red mark on the master bot. By seeing this, the slave robot will be following this. So what happens is that when the master bot is moving, there is a camera mounted on the slave bot. The slave bot camera captures the frame continuously. This is the camera mounted on the slave bot. So the position is like this. So this camera will be capturing the frames, these red frames, and depending on the position of the red frame in the picture, it will decide the turn it is to take. Suppose the red frame appears in the left of the picture, it will take a left turn. If it appears in the center of the picture, it will travel in a straight path, and if it takes a right, it appears in the right path, then it will take a right turn. For doing this image processing, we have used a Scilab's SIVP module, and depending on the different conditions, different values are sent to the slave robot and through the Zigbee module, and depending on these values, the slave robot will decide its direction of movement. So this part was about the object following, and now the obstacle avoidance will be discussed by Chandrapal Singh.
For the obstacle avoidance, we have used 6 sensors. 4 is the proximity sensor, and 5 is the proximity sensor, and 1 is the IR sensor. So when the object in this condition,
suppose my hand is an obstacle, when it comes too close to the obstacle, that this sensor becomes activated and it sends a signal to the slave robot to get a hard turn, and it gets deflected away from the obstacle like this. Similarly, towards the right side, when this obstacle comes too close to this slave robot, that this sensor becomes activated and it signals the slave robot to get a hard turn, and it gets reflected toward this side. In this way, the slave robot avoids the obstacles while from the left side as well as from the right side, and it continue to progress and it continue to follow the master robot. We will illustrate the whole project with the help of a demo now. So here the slave robot is rotating, and right now it is scanning for the red color object. Here the master robot is moving and the slave robot is following it. The master robot as well as the slave robot both have the module to avoid the obstacles. You can see that the slave robot is following the master robot while avoiding the obstacles.
I will be telling about the challenges and the future work which can be done in this project. So the challenges, like for the scanning the red color, initially the Scilab image processing was very slow, as we are using a order n square method. We are scanning each and every pixel of the image, so detecting the center of the object. So to avoid that, we used another approach, which was an order n approach. So with that, the Scilab image processing became faster. And the future work which can be done in this, like right now it moves at a constant speed, both the master bot and the slave bot. So the slave bot can be programmed to move according to the distance. So if the master bot is far away, the slave bot will move faster, and if the master bot is near, then the slave bot will move slower to this. Then we can also introduce multiple pursuers in this, like multiple slave bots, which will be following the master bot, and they will be trying to avoid collision with one another. So this can be like a scenario where multiple masters and multiple slaves are there, but this would need more sophisticated algorithms. So the bit of intelligence would be needed in the machines. So these are the 2 feature enhancements which can be done in this project.